So we talked briefly about what completion stage methods are. Now we're going to talk about how to group them together. And the reason we're going to group them together, as you can imagine, is there's quite a lot of them, and they actually break up into a number of different categories. So we're going to group them together in the ensuing discussion based on how a stage is triggered by one or more previous stages. And we'll see that there's a bunch of methods that complete after a single previous stage. There's a bunch that complete after both of two previous stages, and there's some that complete after either of two previous stages. So there's basically three categories, and the bulk of them are a single previous stage, but you can see that there's also a fair number that complete either when both previous stages complete or either of two previous stages complete. So here are the completion stage methods that will complete or run after a single previous stage completes. And they're then apply, then compose, then accept, and then run. I'm not going to go through this chart in great detail right now. I'm going to go through these things shortly. But the key things to note is that they take parameters that are functional interfaces like function, consumer, or runnable. They return completable futures. Some things will give you completable futures that will give results. Others give you completable futures that do not give you results. And then they all have interesting behaviors that we'll talk about. I want to focus on the big picture view right now without getting caught up in the nitty-gritty of the details. The big picture view is there's two different sets of these methods. Some are like then apply, then compose, and so on. And then there's also these other variants. And so the then apply, then compose, then accept, and then run methods will run in the invoking thread or in the same thread as the previous stage. And it depends on various factors as to which ones they do. So these are one way of doing things. Then there's also these async variants. So then apply async, then compose async, then accept async, then run async. And the async variants don't run in the same thread as the previous stage or in the invoking thread. Instead, they're going to run in a different worker thread in the common fork join pool, or we'll see that there's other variants that could run in whatever thread pool you gave when you created these things in the first place. And this article here kind of gives you a sense of why you might want to use the async methods. The typical reason for using the async methods is if you have a lot of cores and you want to have things run in the background to keep the cores busy. So there's kind of trade-offs here. We'll talk about those later. So these are the ones that complete when a single previous stage is finished. So these methods are triggered when a single previous stage completes. There are then a bunch of other methods that have both async and non-async variants. And these complete when both of two previous stages complete. So you can think of them as effectively logical AND operation. So this and that, then do something else. And as you can see, we have then combine, then accept both, and run after both. And again, they take different parameters. They either return a result or return void, completable future with a result, completable future with void. And then they have a bunch of different behaviors. And we'll look at some examples of these things. So think of these as kind of merging, joining when both things happen, then the next thing can happen. And then the third category of completion stage methods of this form are the ones that will ones that are triggered when either of two previous stages complete. So apply to either, accept either, run after either. If either of the completable futures complete, then the code is run. And we'll talk about some interesting subtleties there that are sometimes surprising when you first encounter them, like the fact that when one of them completes and the action is run, the other completable future is not canceled. It keeps running, and its results simply ignored, which is maybe a little bit non-intuitive, but it makes sense if you think more broadly about how completable futures are typically used. So those are the main ways of grouping together completion stage methods, and we will now look at these in more detail and give some examples to show how they work.